Today we're going to be doing Unit 6, Notes 1. So for Unit 6, Notes 1, we're going to be talking about the Pythagorean theorem as well as its converse, because we want to make sure that we remember the Pythagorean theorem, and also we're going to learn how to use it in reverse. So let's go ahead and let's just talk about the Pythagorean theorem as we learned it earlier on in algebra. So the Pythagorean theorem says that a squared plus b squared is going to equal c squared. Now remember that a squared and b squared are both legs of the triangle. So that means that a and b are both going to be touching the right angle. So that's how you know that they're legs. And then c squared is always the hypotenuse. Okay, so the hypotenuse is always sitting directly across from the right angle, and it doesn't actually touch the right angle. So let's go ahead and let's just practice calculating out a couple of sides using the Pythagorean theorem. So here we have two legs, so that's our a and our b. So 6 squared plus 15 squared needs to equal x squared. Well, 6 squared is 36, 15 squared is 225, and that's going to be equal to x squared. So when you add those two together, you end up getting, so you're going to take 36 plus 225, and you end up getting 261. So now what you need to do is take the square root of both sides, because we want to know what x is, not what x squared is. So once we take the square root of both sides, we end up getting 16.16. Again, remember, whenever you have a decimal, you want to make sure that you are watching your rounding. Okay, so make sure if it's 5 or greater, you round up. If it's 4 below, you keep it the same. So let's take a look at this one. This one we know 7 and 17. Again, both of those are legs, so that's our a and our b. So 7 squared plus 17 squared is equal to x squared. Just as a side note, it doesn't matter which one you pick for the legs. Okay, so 7 squared is going to be 49, 17 squared is 289, and that's going to be equal to x squared. So 49 plus 289 is going to give me 338, and that's going to be equal to x squared. So I'm going to go ahead and take the square root of both sides so that I can just get what x is equal to. So that's going to be 18.38. So that's my final answer for number 2. Let's take a look at number 3. So what I noticed for number 3 is I have a leg and I have the hypotenuse, which is sitting across from that right angle. So because it's the hypotenuse, that's going to actually be our c value. So that's going to go on the other side of the equal sign. Then I have 9 squared and I have x squared. So let's go ahead and let's solve this for x squared. So 9 squared is going to be 81 and 11 squared is going to be 121. So we're going to subtract 81 from both sides, and then we get x squared is equal to 40. So now I don't want to know what x is, so I'm going to take the square root of both sides, and I end up getting 6.32. So that's my final answer for x on number 3. Now, let's go ahead and let's take a look at a common Pythagorean triple. So what does that mean? That means if you have the length 3, 4, and 5, that's going to be a right triangle. 3 and 4 are the legs, and 5 is the hypotenuse. So let's go ahead and let's take a look at some different versions of that. You could also multiply it by 2, which means that 6, 8, 10 is also a right triangle. You could multiply it by 3, which means 9, 12, or 15 is also a version. So really, you could multiply it by any number as long as it's those 3 numbers. So 3n, 4n, and 5n. No matter what your multiple n is, you'll always create a right triangle if you use 3, 4, and 5. Now the same is going to hold true for 5, 12, and 13. So basically, if you were to test it out, you would see that 5 squared plus 12 squared is equal to 13 squared. That's what makes a Pythagorean triple. That's also always going to be true. As well, its multiples are going to be true. So let's go ahead and let's multiply that out. So I have 5, 12, and 13, right? So I times each of those by 2, and I get 10, 24, and 26. That's a Pythagorean triple. You can also multiply it by 3. So you multiply each number by 3, and you get 15, 36, and 39. You can also multiply each of them by n, and no matter what n is, if you multiply it by 5, 12, and 13, you will always get a Pythagorean triple. The last one that's a Pythagorean triple is 7, 24, and 25. So you can multiply each of those by 2, and when you do that, you get 14, 48, and 50. When you multiply each of those by 3, you get 21, 72, and 75. And when you multiply each of those by n, it's going to be the same thing, 7n, 24n, and 25n. So those are your final answers for the Pythagorean triples. Now, let's go ahead and let's take a look at what is the converse of the Pythagorean theorem. So when we're talking about a converse, if you look and you test out the sides and you find out that a squared plus b squared is equal to c squared, then it's going to be a right triangle, if that is true. Okay? Then, if c squared is less than a squared plus b squared, then ABC is going to be an acute triangle. So that means it has acute angles. So what does that mean exactly? So when you have this, that means that your c squared is going to be really small. So your c squared is going to be smaller than your a squared plus b squared. So if your a is or c is smaller, then it's an acute triangle. For this next one, if c squared is greater than a squared plus b squared, then it's going to be an obtuse triangle. And an obtuse triangle, remember, has at least or only one obtuse angle. So that means that your c squared is going to be really big. So it's going to be bigger than your a squared plus your b squared. Okay, so let's go ahead and let's take a look at these next ones. So we want to determine whether each set of numbers can be measures of the side of a triangle, and then we need to classify those. So if you think back when we were trying to figure out if something was a triangle, what we did was test the sides. So we would take the two smaller sides, which is 7 plus 14, and we need to make sure that it was bigger than the larger side. This is not squaring. Right now we're just testing the sides to see if it's a triangle. So then we get 21 is greater than 16. So yes, it is a triangle. But now we need to figure out what type of triangle. So to figure out what type of triangle, we're going to take 7 squared plus 14 squared, and we're going to see if that's going to be equal to 16 squared. Well, 7 squared is 49, 14 squared is 196, and that's going to be equal to 256. So now we're going to add 49 plus 196, and we get 245. That's not equal to 256. So what I notice is that my c squared is greater than my a squared plus b squared. So that means that this is going to be a triangle, and it is also an obtuse triangle. So let's take a look at B. So first we need to figure out if it's a triangle. So to figure out if it's a triangle, we're going to take our two smaller sides, and we want to make sure that it's bigger than the larger side. Again, no squaring. We're just trying to make sure it's a triangle. So then I get 49 is greater than 41. That's true. Check it off. This is a triangle. So now we need to figure out what kind of triangle. So we're going to take our two smaller sides. Oops, I need 40 there. And square it. And then I'm going to set that equal to my biggest side, or my c squared. Well, 9 squared is 81, 40 squared is 1,600, and 41 squared is 1,681. Well, when I add those together, I end up getting 1,681 is equal to 1,681. Well, since they're equal, that means this is going to be a right triangle because they are equal to each other. Now, let's take a look at letter C. So first thing we need to do is make sure that it's a triangle. So I need to make sure that 1 plus 7 is greater than 8. Is 8 greater than 8? Well, it's asking us that it's strictly greater than, not equal to. And no, 8's not going to be bigger than 8. So no, this isn't even a triangle, so we're not going to go any further because it's not a triangle. Now, let's go ahead and let's take a look at number 6. So number 6 wants you to find x. So this is a leg and this is a leg. So x minus 5, quantity squared, that's going to be a leg. 8 squared is going to be a leg. And x squared is going to be a leg. So now, in order to square this, you can't just distribute the exponent in. Remember that this is the same as x minus 5 times x minus 5. So in order to solve it, you need to use the box method. So you get x minus 5 here and x minus 5 here. So now we're going to multiply into the box. So x squared times x, or x times x, is x squared. Negative 5 times x is negative 5x. I hope you guys are having flashbacks to algebra. Negative 5 times x is negative 5x, and negative 5 times 5 is 25. So then I get x squared minus 5x plus 25. Well, I add these two together and I get 10x. So I get x squared minus 10x plus 25. So I'm going to put that up here in place of this guy. That's a 10, not a 16, plus 25. And then 8 squared is going to be 64. So I'm just going to bring that on down there. And that's going to be equal to x squared. So let's go ahead and let's simplify that out some more. So I get x squared minus 10x. Now I need to do 25 plus 64, and that's going to give me 89 is equal to x squared. Well, let's go ahead and let's bring this x squared onto the same side as the other x's. So when I do that, I'll notice that these x squareds cancel out. So then I'm left with negative 10x plus 89 is equal to 0. Remember, the other side of that equation doesn't just disappear. So I'm going to go ahead and subtract 89 from both sides, and I get that negative 10x is equal to negative 89. So that 10 is being multiplied by the x, so I'm going to go ahead and divide both sides by 10. Negative 89 divided by negative 10 is going to be 8.9. So that is what x is going to equal, is 8.9. Last but not least, let's take a look at this last problem. So I know that this is 15, this is 15, this is 12, this is 12. So we want to find the perimeter. Well, in order for us to get the perimeter, I'm going to need to know that side. I need to know what that length is. So I'm going to look at this as a separate right triangle. This has a side of 7, 12, and x. So my right angle is here. So what I'm given are two legs. So 7 squared plus 12 squared is going to be equal to x squared. 7 squared is 49, 12 squared is 144, and that's going to be equal to x squared. Okay, so when I add those two together, I get 193 is equal to x squared. So in order to solve for x squared, I need to take the square root of both sides. So I end up getting that x is equal to 13.89. So 13.89 is the length of this side right here. So to get the perimeter, I'm going to add all of the outside lengths together. Okay, so to do that, I'm going to do 7 plus 15 plus 12 plus 15 plus 13.89. So for the perimeter, when I do that, I end up getting 122.89 centimeters. So now, in order for us to calculate the area, we have to calculate it out in two pieces, because this is not something we know how to calculate the area of. So what we're going to do is first we have a rectangle. I have a rectangle with a height of 12 and a length of 15 centimeters. So to get your area of a rectangle, remember you do length times width. So 12 times 15 is going to give me 180. So that's the area for just the rectangle part. And now I want to find the area of the triangle. Well, I have a height of 12 and a base of 7. Well, the area of a triangle is 1/2 base times height. So I'm going to take 12 times 7, and that's going to give me 84. So then I'm going to take 1/2 of 84, which really is the same as dividing by 2. So then I get 42. So now I'm going to do 180 plus 42. And when I do that, I end up getting 222. Now that's my area, and it's going to be labeled centimeters because that was our unit of measure, but I'm going to square it because we're talking about area. So that concludes your note video for today. Thank you for listening.